All right, so this is a lesson on slope of a line. Now remember, we talked about this a good bit last year. Slope is a measure of a line's steepness, all right? So when we talk about in a coordinate plane, you have to add the dimension of which direction the line goes, and that has to do with whether it is a positive or negative sloped line, all right? We find the slope, it's the ratio of vertical change to horizontal change in moving from one point to another. So let's just talk about that first. I mean, you see, what is this thing right here? This is particularly this. This is this y2. That's the slope that's the formula for slope. M equals y2 minus y1 over x2 minus x1. The change in the y's, that's your vertical change. I mean, that triangle right there is the Greek symbol for delta. It means change in science and math. So it's the ratio of vertical change to horizontal change. We also kind of have a slang version of that. We say rise over run. We use the letter M. If in M, nobody seems to know where that come from, and you Google it on the internet. It's just some, few hundred years ago or so, people started using M to denote slope, and it's kind of stuck, but nobody remembers who started it. Question? Saw a hand up? Okay, so let's look at this. Let's consider this, like if you consider this to be a ramp and you wanted to measure its steepness, you can see that if we move from this point to this point, that's a rise of 3. So that would give that's the vertical change. That's your numerator in the slope calculation. Its run, when you move, its horizontal horizontal change from point to point is 6, all right? So the slope for this, the measure of the steepness for this segment or this ramp is 3 over 6, or you can simplify to 1/2. Yes?
Can you solve it like the negative way? Like go down?
Sure, absolutely. So it's going to have a positive slope, but we could also think of this, what she's getting at is if I thought of going from this point, let me get a little thicker marker here. If I thought of going from this point to this point, I would go down 3, and we'll talk, that's on the next page of this, by the way. That's down 3 and left 6, but that still equals positive 1/2 because it's a negative divided by a negative, all right? So that's that ratio right there, all right? So remember, slope is a ratio, so it doesn't matter which 2 points you pick on the line, it'll always have that same ratio, all right? So let's see. Hang on a second. Pause this a second. Next question is, we're looking at this one right now. We're looking at this one right here. Would my slope change if the ramp was shortened? Notice that the rise was 3 on the last one. Did anything change? Is the slope different on this one? No. Why is it not different even though I made the ramp is not as high now?
You're still going up 1 and over 2.
Right. So because I haven't changed the ratio of the vertical to the horizontal. Before it was 3 over 6, and now it's 2 over 4. Okay, all right. Now let's look at this one down here. So what I've said there is looking at the original ramp. One way I could make the ramp steeper is to increase the rise. So notice that I kept from the original one now, right? Remember the original run was 6. Now I made the rise 5. All right. So is the slope different now? Yes. And is it steeper or less steep? Steeper, right? So the higher the absolute value of the number, the steeper, right? So a slope of 5, 6 is steeper than 1/2, right? That should be fairly obvious. Now remember, another way to increase slope is to decrease the run. All right. So remember the original rise was 3, and notice now instead of it being 6, I made it 4. So this now has that ramp right there has a slope of 3/4. Now, is that more or less than the original one? Is 3/4 more than 1/2?
Yes.
All right, it's a little bit steeper, right? Not a lot, but a little bit. Okay, you go. All right, so let's just make sure we're clear on positive and negative. Remember, if I ever asked you what is a steeper line, a slope of -1/2 or positive 1/2, Corey, what would you say if I said what has a steeper line, a line with a slope of -1/2 or one that has a slope of 1/2? Well, you can just look up there and know the answer to that.
It was saying,
Thank you. So it's just, so remember, steepness, even though a lot of people say slope is the steepness of a line, it really means a little bit more. It means the steepness and the direction of the line. So both of these lines have the same steepness. Now they travel in different direction, and that's where the negative, whether it's a negative slope or a positive slope, comes into play. So the line on the left, notice that's a negatively sloped line. Lines that travel from up to the right, up to the left, down to the right, that's a negatively sloped lines. Lines that start on the lower left and move up to the right, those are positively sloped lines. So you can count, you should be able to look at a line and know if it's positive or negative. If you forget, you can always figure it out, but you should know you should have an idea looking at it. Now, why is this one negative? If I move from this point to this point, my rise is down 3, right? And my run is +6. So that would be -3/6. Or if I go from this point to this point, my rise is 3 and my run is -6. Either way, I'm going to get a slope of -1/2. So remember, moving to the right is positive, moving to the left is negative, moving up is positive, and moving down is negative, right? So over here, either way you do it, and that's what Morgan was kind of getting at. If I go from here to here, I'm up 3, right 6, so it's +3 +6, 1/2, or down 3, left 6, that's -3 -6, and that would be also +1/2.
So just think your slope be going the other way.
Well, the slope's going the same way regardless of which I go from which point to which point.
That's what I'm saying.
Yeah. Yeah. Okay? All right, next. All right, so let's look at this one. So now listen, you're not very often, I may put a problem or two on there where I give you a visual. You're going to have to do this without visuals, but let's make sure we can always think of what would actually be going on a graph, because I don't even know if any of the problems, very few of the problems in the homework actually even involve a graph. So, but you're going to have to understand what's happening there. So if we do this, if I go from the point 3, 1 to 7, 7, that's going to be a rise of what? What's my vertical change? Vertical change of 6. My run is 4. So what would be that slope?
negative.
I'd call it, no, it's positive, right? It's positive. So that's a slope of 3/2. Now notice I have in this table up here, what's my change in y from point to point?
+3.
It's +3, right? And so even though those points are different, or I've got 5, 4 in there, and going from the x's, that's +2, right? So you can see it there. So vertical change over here, right? Horizontal change over here. So that's still 3/2. Doesn't matter which points we pick. Yes, Morgan?
Is -3/2 the same as 3/2?
No, see, -3/2 would be a slope like this, right? This would be a -3/2 line. See that?
Oh, yeah.
That would be a -3/2 line. Because I'm going down 3, which is -3, right 2, that's +2. But here I'm either going up 3, I'm going up 3, right 2, or down 3, left 2. I'm either 2 positives or 2 negatives. Okay? Yes, Jordan?
Even if you started at 3, 1,
Right.
you went to 5, 4, it would be the same.
Right, yeah, that's that, if I did that, that would be up 3, right? That's plus 3, and right 2, right? I still get it. That's why it doesn't matter what 2 points we pick. All right? So what about this one? Another positively sloped line. I didn't actually, well, I gave you some points in the table. Doesn't matter which 2 points I pick. So everybody kind of look at that and tell me what you think the slope is. All right, I'm going to actually use the formula for this one. I'm going to pick the points 2, -1, or 2, +1, and 1, 7, because you're really going to have to use the formula in the homework. Remember, what's my formula? Y sub 2, that means the difference of the y's over the difference of the x's. Now, how do I know which one's which, and does it matter? Does it matter? Not really. I'm going to call this point 2. As long as they're both point 2, meaning x2, y2, call this one point 1. Whoops. Sorry. So that's point. Now, so how do I fill in the formula here? M equals, what's y2? That's 1, right? 1 minus 7, right? Over -2 minus 1, right? So I get -6 over -3, or +2. You can definitely express slopes as a whole number, just realize that means 2 over 1. So we can see that if I go from this point to this point, that would be what? That would be up 6 and right 3. Or down, let's say I go from this point right here. Let's say if I go from this point right here to this one, so this one to this one, that would be down 12, right? Left 6. I still get 2 over 1. All right?
Always be the rise.
What's that now?
Will y always?
Yes, yes, yes. You got to stay consistent with that.
Do you have to do the y1, y2?
Well, the thing is, you're not going to be given the graphs most of the time. You're just going to be given points. So, all right, quiet please. Got to keep the background noise up. Okay, so I haven't really given you anything here, so how are you going to get it this time?
Look at our graph.
Yeah, you better figure out, so let's do it both graphically and with the formula. So pick out a couple of points, and doesn't matter which 2 you pick.
Yep.
All right, the recording's still on. Please keep the noise down. So that's m equals, on picking 2 points, I got -3/2. The points I'm going to select to use are -5, 0 for my slope formula, and I'm going to pick 1, -1, -6, and I should get the same thing, right? So m equals, let's call this time I'm going to call this point 1, just to show you it doesn't matter. This one will be point 2. You can do a totally separate calculation if you want. Whoops. I keep writing. So that's y2. So y2 is -6 this time. y1 is 0. x2 is -1. x1 is -5. So it's minus -5. So be real careful with your signs. Yes, so that will get me, once again, -6 over +4, because it's -1 plus 5, right? So once again, I get -3/2. Now, you might get where the negative ends up in the denominator. That's totally fine. If you got 6 over -4, you're still getting -3/2. Everybody ready to go to the next one? Okay.
Can you go back to the other one?
Yep. Hang on, let me pause it here. All right, so on this one, notice you have, so I haven't given you a line, I haven't given you any points, but I've given you an equation this time. So we need to come up with, from this equation, a couple of points. So it doesn't really much matter how we do that.
Make x equal 5.
Okay, yeah, we could do that. Timothy had his hand up. I'm going to go with that, though.
So, this is the y equals an x equals.
Well, no, we're not going to do that quite yet. I just need a couple of points so I can calculate my slope. But actually, some of you already realized that the slope is there, but let's calculate it.
Okay. So, we can make x
Keep it simple.
7.
Let's keep it simple.
Okay.
How about x 0?
Okay, x equals 0 and y
So-
can be 3.
Okay, so x equals, so that would be y equals negative 3 times 0 plus 7. So y would equal 7, right? That's actually your y-intercept, right? When x equals 1, what's the y going to be?
7.
Not 7,
No. Yeah, that's the other one.
4. So the 2 points I'm going to use for my slope formula are 0, 7, and I'm going to use 0, 7, and 1, 4. I haven't even drawn, I'm not sure I'm even going to graph this. I can if I want to, but, so what's my slope formula? Let's call this point 1.
Well, we already know the slope because it's.
Yes, we're just verifying it though. Okay, that's point 2. So m equals 4 minus 7 over 1 minus 0. So what do we get? We get what we're supposed to. Negative 3 over 1. We knew that already. Those of you who remember slope-intercept, that negative 3 is the slope. Okay? Question, Drake? Nice and loud, bud.
If x equals 0, or x equals 1, why do you have x equals 1?
I just needed to, I wanted to use the slope formula to get my slope, and I needed to just get 2 points. And so the way I created one of the points was give x a value in the equation, whatever y is, that makes it a point on the line. All right, now I have 2 points in the line, and what I did up above there in the upper right was plugged in the slope formula.
So x can equal anything?
Yes, x can equal anything, right? The only reason I didn't use those other guys was just going to get some big numbers, and I didn't want to deal with the big numbers. All right, now here I just given you a point, so that should be easy enough. All right, everybody go ahead. I'll pause the recording. Everybody calculate the slope for these 2 points, and then we'll turn it back on, see where everybody gets, okay? So did everybody get those 2 values for your slopes?
Oh, I didn't find the same.
Let me ask you something. Would these lines be, what's that?
I got 1 over 4 because it was negative 1 divided by negative 4.
But remember, it's negative 4 minus negative 5. That's going to negative 4 plus 5, or positive 1, right? And then negative 1 minus 3 is negative 4.
Wait, no, because it would be negative 5 minus negative 4.
I'm looking at the one up above, I think. No, I'm not. So negative 5, well, if you did it that way, let's just show you. So you would get the negative in the numerator and a positive in the denominator.
I got negative. I did negative 1 minus negative 3. Minus 3. Minus 3. So that would be negative.
Negative 4.
Negative 1 4.
It's negative.
Okay, so look, I've got negative 4 minus negative 5. That's negative 4 plus 5, or 1.
4 over 1. Because the negative 5 and the negative 4 is the y.
All right, hold on. We're getting there. Okay, let's talk about slopes of parallel lines. Slopes of parallel lines.
Are the same.
Well, that's right. Good, Max. You remembered that. Okay, so, but let's show you why. No, that's good. All right, so let's just make a couple of lines. I'm going to put a point at 0, negative 2, and I'm going to go up 4 and over 3. Okay, so make sure you use the same ratio. I'm going to go up 4 and over 3 just to make it easy to sketch my line, right? All right. Now, what is the slope of that line? because I went up 4 and right 3. So what's the slope? We'll call that line A. So the slope of line A is what? 4 over 3. Now, if I want to create a line that has the exact same slope, I just merely want to change where the line is, right? Use a different y-intercept. That would do the trick, right? I'm going to start this one at positive 2, and I'm going to go up 4. 1, 2, 3, 4, and over 3. And I could also go down 4 and over 3. And you can see that as long as I have the same slope, the lines will be parallel, okay? That means they'll never intersect, and they'll always have the same space between them. So both of those lines, line A and line B, have the same slope. And that's what makes parallel lines, right? Same slope is the idea there. Any questions on that? Okay. That's not the one I want.
Can you go back?
It would be logical that a horizontal line has a slope of 0 because it's, this floor, if somebody said, I'm going to go get my skis out and put some snow on the floor, I'd have to cross-country ski. I couldn't downhill ski here because there's no slope, right? So mathematically, you could see it as well. If I pick 2 points on here, like this point is 3, 3. This point is -1, 3. When I use my slope, I'll get a slope of 0 because my vertical change, which is my numerator, is I get 0 over 4 here. So horizontal lines always have a slope of 0. Okay? All right. We hit the end. This is the one I want. Okay. All right. Let me draw that same line, that first line I drew before. So that's at 0, -2, and then up 4, right 3. So do that same line, then we'll talk about what would create a perpendicular line. The one thing it's not is just slopes. You can't just change the sign. It's not just change the sign. Like this slope is positive. We'll call that line A again. That slope is 4/3, right? -4/3 does not create a perpendicular line. It's actually going to be the opposite of the reciprocal, all right? The opposite of the reciprocal of this will no, don't confuse opposites and reciprocals. Opposites means different sign. Reciprocal means the number I multiply it by to get 1. Opposite of the reciprocal, all right? So the slope of line B this time is going to be -3 over 4. Now you'll see if I make the slope I started with the opposite of the reciprocal, it will create a perpendicular line. So I'm going to use the same y-intercept of 0, -2, and this time I'm going to go down 3, 1, 2, 3, and right 4, not 3, and you'll see that that creates a right angle.
Oh. Wow.
Okay? So that will create a right angle. So the key there is, the key terminology is, they have slopes. So I'm referring to perpendicular lines now that are opposite of reciprocal. They will always have a different sign, and their numerators and denominators will flip. All right, these left quickly. So the slope of a vertical line is, make sure we know that's undefined.
The next one is horizontal.
Yeah, but go to this one because I'm on the vertical line page. Now, why is it undefined? Let's pick 2 points to see why a vertical line has an undefined slope.
Because it's not, it's just going down.
Well, and I agree with you. It's like, how do you measure the slope of something that's straight down? You can't measure it. That's one of the reasons. But mathematically, you can see why it would be. Let's pick 2 points. This is the point 4, 9, and 4, 6. When you plug it into the slope formula, you'll see you get a 0 in your denominator. So your vertical change is 3, but your horizontal change is 0, so you get an undefined. You can't divide by 0 there, right?
Why are you minus 6? I mean, minus
I don't know why. Thank you. Thank you. Let's fix that.
no.
I went to where it's 9 minus 6. Question? It doesn't matter what I pick there, but I want to get the numbers match up. So it's 9 minus 6. It wouldn't matter what points I pick here. I would always have a number in the numerator because I do have vertical change, but I have no horizontal change, and that's why it's undefined. All right, let's go back to the page